Hey guys, welcome back. Um, I hope that you are okay. This is gonna be like the fourth time that I record this. You have no idea how many issues I have had today with this. Oh my god, and I'm so uncomfortable. My back hurts. Okay, so I hope that you've been doing the concepts that I told you. I hope that you don't. I hope that I don't have to explain to your parents your homework, because it's a homework for the students. You always understand in school, and if you don't, you can ask me in the platform in a private message. And I hope that you are having your questions ready with the specifications that I gave. Cursive with a pen, the questions, and pen with pencil with print, the answer. Again, cursive, pen, the question, print, pencil, the answer. Okay, so let's explore page 79, the third biome. Okay, so let's do this. When we think of deserts, most of us think of very. Oh, sorry, I didn't tell you the page 79. Oh, I did, right? Sorry. 79. When we think of deserts, most of us think of very hot, dry areas of sun with no water for miles. But did you know that there are cold deserts too? About one-fifth of Earth's land surface is desert. Much of the southwestern United States is desert. There are also deserts in South America, Africa, Central Asia, and Australia. The largest desert on Earth is the Sahara in North Africa. So as you can see, there's a big portion of the planet that is a compound by deserts. Let's continue. Hot deserts can be arid or semi-arid. Remember the concept of arid? Arid deserts get less precipitation, rain, and have hotter temperatures than semi-arid deserts. Now, arid deserts don't get as much rain as they would need to, and they have something very particular. They get very cold at night. Temperatures range from 70 to 77 Fahrenheit. That's 70, it's kind of like it's a weather that we would know in Honduras, but then with extreme high temperatures of 120 Fahrenheit. That is so hot. And extreme lows of 0 Fahrenheit. Then at night, when it's midnight, it's super freezing cold. Hot deserts get less than 10 inches of precipitation per year. The Sahara Desert, for example, get less than 1 inch of rain every year. So they get, I would say that an inch is like this, I'm guessing. And that's what they get of rain every year. That's nothing. That's no water. And it's so dry that when as much as it rains immediately, it gets sucked by the sun because it's so dry and hot. The few plants that grow in hot deserts have developed adaptations that allow them to survive for many months with no water. The cactus stores water in the folds of its trunk. It uses the water during the long, dry months. The cactus also has a waxy covering on its trunk to keep the water inside from evaporating. Its spines protect the trunk from animals that try to bore holes in it to drink the stored water. So we have in there that sometimes the only plants that can survive in a hot desert are plants like cactuses, that they can hold all the water inside themselves, and they have waxy surfaces. The outside part of them, of the cactus, is waxy like a candle, so it's kind of like shiny and plasticky, so the water from it doesn't evaporates. For an example, if we take another kind of plant, let's say an apple, if we leave it outside for a long time, it's gonna start getting drier and drier and dry, a little wrinkly or wrinkly, um, and eventually it's gonna lose all the water. It's gonna get rotten. So because the hard covering outside them, it's still kind of moisty, so all the water inside of the fruit can be evaporated. In the case of the cactus, it protects itself with the waxy surface. Let's continue. Arid desert animals have also made adaptations. Remember that we said that adaptations are really important? Adaptations. Did I write it correctly? Oh, I did. Okay. Dromedaries or camels have double rows of eyelashes to protect their eyes from the desert sun. Because it's so sandy and sometimes it's so windy and there are sandstorms, they have a double set of lashes that protects their eyes so they don't get sun on their eyes. They can also raise their body temperature so that they do not sweat and lose water. They are not ectothermic. They are not ectothermic because ectothermic it's well, this is a confusing one, so I don't want to confuse you. So because they regulate their temperature, they are not ectothermic, because ectothermic means that you cannot change your temperature. In this case, they can change their temperature. If it gets too hot, they get hot, so they kind of level their temperature. I'm really hoping that I can explain this to you in a way that you understand it, you don't get confused. Took me a while to understand it. So we could be ectothermic. We could be not ectothermic because our blood is warm, but when it's too hot, it regulates the temperature. So we are in a level, there's an equilibrium in our bodies to the temperature outside. So if we take a cup of coffee, we can warm up our bodies inside, so it regulates the temperature and we feel a little warmer. But then we have other animals that are actually ectothermic. Sorry, neighbor with a motorcycle. Okay, so the ones that are ectothermic, for an example, are the iguanas. So this is according to what I researched in the internet. So if I'm incorrect or if you think that I missed something, let me know, okay? So iguanas are ectothermic because they can change the temperature. Their blood is constantly cold. So as much as they cannot take a cup of coffee to change their internal temperature, what they do is that they go under the sun to protect themselves from the heat, or when they're too cold, they go outside to the sun. That's why sometimes your mom says when you're in the sun, you're like iguana because you're in the sun. You're like a garrobo. You're looking like a garrobo in the sun all day. Because they stay on the sun, so they keep warm because their blood is cold. Okay, reptiles are ectothermic. They cannot regulate their body temperatures like mammals can, so the body temperature depends on the outdoor temperature. They use the sun to keep warm and sometimes go underground to keep cool. See, I just explained that. Kangaroo rats are one of many desert animals that are able to get water from the foods they eat. These small desert rodents extract their water from dry seeds. Desert animals are mostly nocturnal, coming only at night. So we have the kangaroo rat is a small rat that I told you in the vocabulary that stays in two legs, and they have very long ears. That's what they kind of related to the kangaroo and the position that they stay in. And because it's a very dry area, what they do is that they go and they try to find seeds of different plants, and they eat them, they nibble them. So they try to find the water inside of those seeds. Now, these kind of animals in the desert biome are mostly nocturnal because the temperature is so hot that they rather go outside at night when it's fresher or super cold because it's easier for them to do some things. Nocturnal, coming out at night only. Other desert animals come out just before dawn or dusk. Nearly all desert animals spend the hottest part of the day underground, away from the nearest intense heat. Scorpions. No. Scorpions are bad, and they like the hot weather. Cold deserts get about 10 inches of precipitation annually. Most of this precipitation, rain, is snow. The winter temperatures in cold deserts range from 28 Fahrenheit to 39 Fahrenheit. Animals in cold deserts burrow underground for protection from the cold. Antarctica, the Gobi Desert in Asia, and the Great Basin Desert in the United States are cold deserts. Now, before we continue with the next biome, I'll give you the question that I will assign you based on this. So copy it next. I don't know if it's 3 or 4. I think that it's 4. I don't know. You just like you have to follow the order. So the next one will be describe the desert biome. Describe the desert biome. And remember, don't Google it. Don't copy word by word what's on the book. Use what I told you in the explanation and use your own words, or your answer is not going to be correct. And in there, you have to explain, describe animals. That's the next one. Animals that are ectothermic and not ectothermic. You have to describe them. You have to say human is ectothermic and camel is ectothermic, and so we can have examples of what kind of animals have this different kind of like regulation of a temperature. So the next one would be describe animals that are ectothermic and not ectothermic. Okay, next, page 80. Grassland biome. Grasslands are appropriately named because they are covered with grass. Very clever, right? And have very few trees. They have found all over the world in both temperate and tropical climates. Grasslands are often located between a desert and a forest. So that's the middle of the temperature because the desert is super hot and the forest is kind of humid. Temperatures are usually mild and precipitation averages between 10 and 36 inches per year. There's some good rain in there. About 1/4 of Earth is grassland. There are two types of grasslands, temperate and tropical. Two types of grasslands, remember that. Some temperate grasslands are moist and humid. Ooh, that would be uncomfortable because that's kind of weather that you that is hot, but it's not only hot, you feel sticky because it's very humid. But others are semi-arid. In humid grasslands, the moisture helps grasses to grow very tall. The grasses remain shorter in semi-arid grasslands. The eastern prairies of North America and the pampas of Argentina in South America are humid. Grasslands with tall grasses. North America's western prairies are semi-arid and have short grasses. So as you can see, it depends of the precipitation that they get during the year that makes these kind of grasslands to grow the grass. Now, we will see in there what happens when there's no precipitation and the grass remains in a different color. Tropical grasslands are also called savannas. So we were talking about temperate grasslands are the ones that get a little more rain and they keep the moisture in the humidity. Now, tropical grasslands are also called savannas. Savannas are found in East Africa and Australia. The climate in tropical grasslands is warmer than the climate in tropical grasslands. In temperate grasslands, sorry. I'm going to read it again so we don't get confused. Tropical grasslands are also called savannas. Savannas are found in East Africa and Australia. The climate in tropical grasslands is warmer. So they are not as fresh because remember, yes, it's humid and yes, it can be sticky, but also can give you some fresh feeling if you're not under the sun with the humidity. Humidity can be also positive. Humidity is that kind of like wet cold that you feel when it's so cold that you sneeze, or when you're so cold that everything you touch is wet. That is humidity. Humidity is the quality that something has to retain the water inside of them. So in the case of the temperate grasslands, they can keep their water inside of them and create this humidity that keeps them warm-ish. But in the case of the tropical grasslands or savannas, they are a little warmer because they lack this humidity. They don't have the ability to absorb the water the same way and retain it the same way. The climate in tropical grasslands is warmer than the climate in temperate grasslands. The tropical grasslands have both dry season and rainy season. Little rain falls during the long dry season. During the rainy season, it might rain every day. So something that we should notice in there is that in these savannas or tropical grasslands, it might rain every day depending on the season, but sometimes it doesn't rain. And what happens to the grass is that they absorb the water that they had and they just green out, they blossom being green. But the problem is that when there's no water, then they're not completely green, they turn into a grayish brownish kind of color. 81. The grasses in grassland regions have adapted well to their environment. They have long taproots that grow deep into the ground. These long roots can tap into the groundwater during dry periods. When water is no longer available, grasses will become dormant. See, that's what I was telling you. When there's no water for the grass, because these grasslands are full of grass, they dry and they kind of like, they just go to bed, they sleep until the water reactivates them and they can go back to action. And turn brown until the rains come. The complex root structure helps the rich soil from being blown away by the strong winds. The rich soil helps replace grass eaten by animals or burned by brush fires. Just like in here. I don't know if you've seen it, but going to El Sitio, there's always fires, always, all the time. But like months later, you will see that the grass has become green again because grass has that ability. Even if you burn the surface of it, the roots, the tap roots that they have are so strong that they blossom again into being something green. The grasses provide an excellent food source for a variety of animals. Species. Many of these animal species are migratory. They move to find grass for grazing. Some are also fast runners and can escape the frequent fires. Animals found in the temperate grasslands make adaptations to the seasonal changes. They grow a thicker coat of fur during the winter months, or like the bison, have a keen sense of smell that they use to detect the grass under the snow. So these kind of animals, again, adaptation is very important because they have to adapt to the different seasons that every biome goes, because otherwise they have to migrate. They have to move from one place to another until they find a place where the weather is good for them and they feel comfortable with it. So it's very important that we notice how they get more fur during the winter, or hair, fur, or they get less during the summer because it's hot. So, the question that you will answer about the grasslands is the first. You obviously going to have to write, describe the grassland biome in your own words. Don't Google and don't copy everything from the book. Use the comments that I gave you. And you have to write the description of how the grassland is, where is it located, and etc., etc. Remember, we've been doing 6 to 7 lines by every question. So you will basically do the same, 6 to 7 lines. And then you will describe the difference between temperate grasslands and tropical grasslands. That will be the next. So the first one of this part of the grasslands will be describe grassland biome, and the next one will be identify the differences between temperate grasslands and tropical grasslands. You have to describe the concept of each of them and then tell me what is the difference between them and what are the things that are in common between them. So this one will be probably 14 lines, because in 7 lines you are going to describe the tropical grassland, and in the other 7 lines you are going to describe the temperate grassland, and then you have to write in small in there what are the differences and the things that they have in common that made them so different from each other. Okay? So these are going to be the questions for this part. I hope that I can see you tomorrow, and I hope that you're understanding everything. Remember your questions in the notebook, the question in pen in cursive, and the answer with a pencil and print. And I hope that I see you soon.